we are gasifying biomass to actually substitute fossil fuel in energy processes, but also for heating, but also for the chemical sector. So we have this plant down in Höganäs in southern Sweden, and from there we are now commercializing the technology. So our company has been around for a while. We started 16 years ago and started in a small scale in KTH University here in Stockholm, building our first test plant in 2009, our first gasifier to 2011, located 1.5 hours west from Stockholm, a place called Köping, where we built a complete integrated plant and ran over 30 different biomasses through the process before we started the project in Höganäs and building a first industrial scale plant. And this is a 6 megawatt plant that we now have started and operated 24/7. And we're now moving on to start delivering gas to Höganäs. So we have a portfolio of new possibilities, new projects, and it's actually divided in different applications. So it's about green hydrogen, it's about green methanol, also combined heat and power, even here in Sweden nowadays. And it's also what you can refer to as a biorefinery, where you actually use biomass to substitute all parts of fossil products like diesel, like jet fuel, gasoline. So these are a few of the projects here and near. We are located, our operation here in Kista outside Stockholm. We have the test plant in Köping and the industrial plant down in Höganäs in Scania here in Sweden. We are working with a very interesting project in Norway, Biojet, actually producing diesel. It has been a very big challenge, and we have learned so many new things regarding how to implement our own technology in a more demanding processing. The company has 34 employees today, where about 20 of the persons are in Höganäs and the rest are in the Kista office. So what do? We have this gasification of biomass. So what do? It's 5 steps that we show here. It's drying. I mean, simply just like a big tumble dryer to get the dryness down to have less than 5% humidity in the biomass, and then we make pyrolysis, number 2 here. And pyrolysis means no air. We make like a charcoal, like barbecue kind of looking charcoal, and then we take this carbon product and we mill it to a very fine grain, but below 1/10 of a millimeter, and start injecting this with steam in the gasifier, the 4th step. And now we are in a temperature of 1100 degrees. Steam and carbon reacts quickly, and we generate a gas which is mostly hydrogen, 60% hydrogen, 30% CO, a little bit of methane and the rest CO2 in that. We cool it down in number 5 here, a cooler, where we get the steam that we need for the processing. And number 3, you see here, is actually where we fire the pyrolysis gas that we get from number 2. And we use then the flue gases, the hot flue gases from heating the gasifier to heat the pyrolysis, and after heating the pyrolysis, heating the dryer. So in that respect, we can be very energy efficient in the processing. We have tested, as I said, lot of different biomasses and different kind, from industrial waste to woody stuff, and it works. It has its own recipes. One can say that one unique feature to what we're doing is actually also the high energy yield, being more than 80% of the energy in the incoming biomass into the gas in the end. We have a portfolio of patents for this. It's 162 patents and 6 families covering the gasifier, hydrogen production, pure hydrogen production, I should say, the gasifier as it looks, how we inject steam and carbon, making biocarbon to substitute metallurgical coke. It's also about liquid production in this. So all of this in the same platform. So this is a way of seeing our development from the small scale back in 16 years ago to the first testing and building the first plant of 500 kilowatts, 6 megawatts, and now working with big projects also where we go for modular plants like the one you see here as a biorefinery. And this is really the way we go forward with our technology in a modular fashion. The opportunity for renewable energy is good. All of you know that. But the thing is that when we now look upon the pricing that is available for these kind of applications, we see like 100 euros per megawatt, corresponding to 1 krona per kilowatt hour. We see a good return on the plants that we can provide from the 6 megawatt to 20 megawatts and onwards. I mean, this is due to the availability of low-grade biomass. It is the high energy prices that we see in the volatile energy prices in Europe. The CO2 emission rights being at very high prices right now and expected to stay there. It's also that a lot of industries has really woken up and say, we want to go for green energy and we are prepared to pay for it. So the transport sector has been on the green route for a very, very long time, and still there is a lot to do. So, about the Höganäs project, it's 6 megawatt plants, as I said, 2,000 normal cubic meters per hour of syngas. There is a 20-year offtake agreement, and we can save about 10,000 tons of CO2 per year. There is an expansion possibility for us, and this is, well, our reference and where we take new customers and potential customers as we go forward. We had some support from the beginning in the project, which was good at the time and helped us. One other thing that is quite important for a new technology is that we have built, we own, and we operate the plant. And this means that for anyone who wants to buy a plant, we actually have also the organization, how to manage, how to operate this. And we can use that for training the operators, for training the staff for new projects, which actually is it's a good thing for us. We have at the plant proven that we have the full syngas quality from the start. We have done some testing in Höganäs furnaces. We have had some bad issues with char dusting, which we now have resolved. We are testing also some new solutions when it comes to our specific burners that we use. We have run the 24/7 integrated operation, and we are now in a few weeks starting up again and start tests continuously delivering to Höganäs, and that is the important thing for this year in the Höganäs plant. So what happens around new projects? And we then focus on 4 projects as we go forward. It's just gasifiers, two of them for a project in Germany, 0.5 megawatt, 6 megawatts. We have in Ireland a 6 megawatt plant for producing, it says RNG here, biogas. It's methane, actually. And then there are two development projects in one for methanol for shipping, and then the biojet diesel project in Norway. So when we look upon the market for what is the drivers behind these projects, so in Germany, there is a lot of biowaste. There is a change in regulation, and you actually, this is a big driver for getting rid of these type of waste. When it comes to RNG biogas in Europe, there is a decision from the EU to go for 35 billion cubic meters per year by 2030 being a green methane, and that is a huge goal, and it needs every resource available to make that happen. We see on the methanol side, there is a very ambitious goal from the industry to have like 8 million tons per year by 2027. So that needs to move quickly forward. And when it comes to green diesel, it's almost infinite. I mean, we see the electrification, we see hydrogen use and so forth. But when it comes to some more demanding the transport and longer distances, we still believe that diesel will have an important part of that for a long time. Looking on the prices is an interesting thing. One can say that the biowaste in Germany gives 250 euros per ton for the biowaste that you use. So you get paid to take it, so you don't even have to worry about having a good yield or anything. It's just a very good starting point for producing competitive gas. When it comes to biogas, there are different initiatives in different European countries, but it has a big spread, and this is really strong incentives. One can say that the third quarter here, the methanol, the pricing of the methanol in combination with the emission rights you need when using fossil gives a very attractive price. And so for the green diesel, you can look at a gas station and see what the HVO 100 have for price. And when it comes to the project value, from our perspective, it's like the two gasifiers are smaller projects, 2 to 5 million euros. The biogas project bigger, and there is well, actually more down the road than this first one. The methanol is bigger plants, and so is diesel too. There is, of course, time in this. Where are we, and so on. But the lead time for this type of projects is quite long. Fortunately, we are on a good way on all four of these. But that is an important thing regarding this business. It's there are lots of, you have to have permits, you have to have well, environmental building permits, operational permits, and things. So it takes a bit of time in this. But as we put this together in a scenario, so one can say that we then have well, these four projects, and apart from that, what can we see happening in the market now? And one interesting thing is the combination of biomass and electricity, where that is available. Norway or northern Sweden or northern Norway is a good example, like a hybrid solution using both biomass and electricity. We also see the CO2 recovery for improving the carbon yield. I mean, get the carbon to a product, whatever it is, and then of course just normal industrial thinking, energy recovery and integration, and also biocarbon use. So these are good things for us because it helps actually these projects. Hydrogen is our home turf, you can say. We're starting with 60% hydrogen, and we can turn almost all energy into hydrogen. But the interesting thing now is what is happening here and what is happening with the company Cortus Energy. And of course, the most important thing is that we actually started demonstration in April, that we run for 30 days operation from there on, and to deliver gas and get paid for it. We also will work where we can have some spare capacity and use biocarbon as a product on the market and get quite well paid outside Höganäs. But the 4 projects, together with what's happening in Höganäs, we put together scenario, and one can say that what does this mean? It means that we go from a small quarterly turnover to a substantial one within those 3 years. And we can see that the cost for different things, the investment cost in Höganäs goes down, and the project are dominating, and that means things that we buy from outside, both equipment and engineering services. But all in all, it means that we don't see that we will be profitable this year, but we see that we can actually early next year turn this around and get profitable and grow. That is the message. So with that, I'm finished my presentation. Thank you very much.
Well, thank you very much indeed, Rolf. Could you please elaborate a bit on the policy level here? Because you mentioned the emission rights, the prices are very high, well, due to what we call the Swedish model, but that's another story.
Yeah.
You know this. And also the discussion that's going on now in the EU when it comes to biomass. There's the stuff happening. How does this affect you?
Well, I think first and foremost, it is an issue for the whole, the woody countries in the northern Europe. 1/3 of the forests in the EU is actually in Sweden and Finland. So this industry is actually, well, I would say they're fighting back. That's the first thing. But what we see is that there are still a lot of biomass available. And the thing here is whether to use the forest residues or not. And as we can see, there on the one side the biodiversity, on the other side it's actually methane leakage that you get from not doing anything.
From leaving it on the ground.
Yeah. Yes. So those things are balancing the use or not. So what we see is the availability to cheap biomass is here and will stay around for a long time. There will be issues like this, absolutely. I mean, from a sourcing perspective, there is an even bigger thing when all Eastern Russian and Belarus forest coming into Europe through the Baltics is gone. So the pricing in the Baltics has raised enormously. So I mean, this is the market we see, we act upon, but we find still sourcing to a reasonable price.
And there is, of course, as you mentioned before, other types of biomass that is not forest residues. I wanted to ask you about biochar.
Yeah.
How do you work with biochar? Because there's a huge demand now to sequester the carbon and bring it back into the soil.
Yeah. So what we do is actually the intermediate product in our process is actually biocarbon, and so we have used that for substituting carbon products in the steel industry and tested and so forth. And that is absolutely an application for half our system to produce that. And we see also that apart from actually the steel, the metallurgical industry, it's also, like you say, soil improvement things, and that's a real market. So what we're actually doing is that we have for this year, next year, an overcapacity in the pyrolysis. We will produce biocarbon and sell because
you call it biocarbon, not biochar.
I can call it whatever.
Just so you know, it's the same thing. Yes.
I mean, it's like the product has its specifications. When you talk about biochar, there is you have to meet certain conditions to get a certificate for
be able
selling
to actually put it in the ground and make food from it. Yes.
So we are actually in the process of getting that certificate, so we can be part of that market as well.
Because that's also a huge market.
It is indeed, and it's a good thing because then during times when you're not running in an optimal way, you still have products. So it's a good thing to have a versatile process.
Indeed. Well, thank you very much, Rolf. Thank you very much.
Thank you.